Hi there, welcome to Learn to Learn Science, and today we are going to go through a chemistry separates paper. It is the one from November 2021 and it is paper 2. As with any question, we always start by reading it first. So we've got figure 1 shows a list of particles, then figure 1 with our list of 4 particles there, and in the spaces below write the names of these particles in order of increasing particle size, starting with the smallest and ending with the largest. I then always go through and highlight things that stand out. It's a good exam tip. I really would recommend that you do this. So I've highlighted ene, nano, atom and starch because that's what stood out there. Then increasing particle size, starting with the smallest, ending with the largest. You'd be surprised how many people would accidentally get that the wrong way. So make sure you know going forward. And it's with 2 marks. So remembering that we want to start smallest to largest, we're going to start with ethene, and that E stands for alkenes. So we know we're working with an alkene here. We need to remember that alkenes are hydrocarbons, so they are made of hydrogen and carbon only, and they have double bonds. Now, there is a list that we need to know, and you can remember this by monkeys eat peeled bananas, and then filling it in methane, ethane, propane and butane. These go in increasing order of how many carbons they have. So we're looking at ethene today, so we know they have 2 carbons. So drawing the structural formula will include that double bond. We should know that carbon can only do 4 bonds, so therefore we can only have 4 lines of each carbon, and we fill in the blanks with hydrogen. And there we go, there we have ethene. Just going to put that over in the corner so we can still see it for later. Concentrating on the nanoparticles. Now nano normally means you've got between 1 and 100 nanometers in size, and a nanoparticle is actually made of hundreds of atoms. And I'm going to show you a photo here of a picture of a nanoparticle there. Each circle, each dot is representing an atom, and each of the lines is representing a bond. So straight away, hundreds of atoms. Compare that with our ethene. We know that our nanoparticle is going to be a bit bigger than ethene. Moving on to the sodium atom now. The sodium atom is pretty much what it says. It's 1 sodium atom. Okay, so again, comparing it with ethene, which has 4 atoms in it, and nanoparticles, which have hundreds of atoms in it, we've got sodium here with just 1 atom. Then lastly, we have our starch molecule. So this is actually referring a little bit to biology as well. Starch is polymers of sugar units. Remember, polymers are anything that just has a repeating unit over and over again. So starch is just the polymer of sugar. And unlike the nanoparticle, starch isn't quite 100 of units, but it is more than ethene and sodium. So now we can start putting our order together. Remembering that we were going from smallest to largest. So number 1, we have our sodium atom. It is just 1 atom, so it's got to be the smallest. Second is ethene. Now ethene has 4, it's got our 2 carbons in there and our 4 hydrogens. Third is starch, that polymer of repeating units, and 4 is nanoparticle, so don't let that trick you. Even though nano is small, it's still got hundreds of atoms. Here is the mark scheme there, just for reference. Now moving on to B, we have explain a possible risk associated with nanoparticulate materials, and it's worth 2 marks. Again, first thing we do, we're going to highlight bits of the question. They're just worth noting there never is a right answer for which bits you highlight. here. It's just kind of what sticks out to you. So this is what would stick out to me had I been sitting this exam. So the first thing is we're going to explain. So remembering when we explain something, we need to pick a risk and explain it. And the risk here, we need to talk about what can go wrong and why. So this is just how we're going to access our 2 marks, and you would get 1 mark for each. And then just the definition of nanoparticulate materials is that they are substances made up of nanoparticles. They have different properties to the original materials. Now just diving into the question of the risks of nanoparticulate materials. So, possible risk. The first thing whenever we think about nanoparticles is size. It's pretty much going to be somewhere in your answer. So always mention size when writing about nanoparticles. They are really small, that they can enter the body via just breathing. We can breathe them in. So that's a risk. Another risk is something called toxic binding, which means things can bind to nanoparticles, then we can breathe them in. And lastly is the modern day development. They're quite new. So any of them is going to be worth our first mark as a risk. For the second mark, we need to explain this risk. So we've got, for the first one, the size one, that they enter the body, they can cause damage by catalyzing harmful reactions. Toxic binding is because they have a large surface area. Things can bind, toxins can bind, and again, they can enter the body and be harmful. Those are kind of the same point. Picking between one of those, I would definitely go with the first one in the size. And the last one is the modern day development. These are new, so some risks are unknown. We don't have enough data. So there's our reasons. So in the marks scheme, you can get a mark for saying that you don't know the risks fully. Long-term risk isn't known. That is your first point. And then you need to join it together with the reasons. So because they have not been used for a long time, new technology, no long-term research. So both of those are worth 2 marks together. The next one is by passing the body through cell membranes, into the skin, into the bloodstream. And again, your reasoning can then be because you could catalyse or change any reactions in the body. You've allowed cause a change. And over here, I've circled 2 marks and 801. I just want to highlight that this tends to mean memory. So if you ever see, well, you won't say that it's 801, but just a lot of the questions in an exam, especially the start-off questions, are things based on memory. If you didn't know that, it would be quite hard to guess that, I guess. So again, risk, why? It was explain a possible risk. It was worth 2 marks. So you get 2 marks for the top 2 points if you went down that route of not knowing the risks and the modern development, and 2 marks if you went through the risk that they're really small, they can pass through the body and they can enter the bloodstream and catalyse your reactions. So you would just basically need 1 risk and 1 reason. The last part of this question is explain the advantage of using catalysts made from nanoparticles rather than larger particles. So I would choose to highlight explain, catalyst, and then the whole bit of nanoparticles rather than larger particles, because I know I'm going to need to compare. So again, it's an explain question, so we need to make a point and then, explain it, justify it. We need to look at the advantages of the catalysts of nanoparticles rather than large particles, so we need to therefore compare. So in other words, we are comparing nanoparticles as catalysts rather than normal particles. What makes nanoparticles better? It's worth 2 marks, this one. So we're looking into the advantage of nanoparticles as catalysts. First of all, they have a really large surface area to volume ratio. So that would be our point. And then because it's an explain question, we need to make sure that we explain. So because of this large surface area to volume ratio, we have an increased rate of reaction. Remember, this is the kind of whole point for catalyst, to increase that reaction rate. So here is the mark scheme. So we've got catalyst particles have a much larger surface area. 1 mark leads to an increased reaction rate, 2 marks. And then just a reminder that we are comparing. It's worth to say about larger surface area is that it is in the rates of reactions topic as well. And if you think about larger surface area, think about students in a school. If we suddenly made all the students in a school giants and give you really large surface areas, then you're more likely to bump into one another. And remember, bumping in is the whole point of, well, it's the whole way that chemicals react. Another one is that this is AO1, so it's another memory. The whole thing this time around has been memory. And then this is just reminding you that it links to the rates of reaction topic. So the whole total for question 1 is 6 marks. Please let me know how you got on. I hope at some point you managed to pause the video and have a go at the questions yourself. Thanks for watching. I hope you found it useful. If you have any questions or you just want to let me know how you got on, please put it in the comments and I'll be more than happy to look into them. If you want any particular questions for me to help you out with, I'm more than happy to. So please do subscribe to Learn Science for more. I plan to kind of grow this from here.